Hello everyone, in this video we'll be solving problem 3195. Find the minimum area to cover all ones, part 1. The problem statement is we are given a two-dimensional binary array grid. We need to return the minimum possible area of the rectangle that covers all of the ones in the grid. If you look at example number 1, we have a grid with 2 rows and 3 columns. With these 3 ones in the grid, the minimum area or the minimum rectangle that covers all of the one is actually the entire grid. Hence the output is 2 into 3 as there are 2 rows and 3 columns, giving us the output as 6. The problem statement is straightforward and easy to understand. Let's switch to whiteboard and discuss potential solutions. As we are looking to find out the minimum area that will cover all of the ones, the row and column that we select to be the boundary of the area should have at least one ones in it. That is, any row or column which do not have any ones should not be included in this area. Let's start with identifying the information that we need to build this rectangle or the minimum area. As it is a rectangle, we need the length and the width of it, or in other words, we need the starting point and the ending point of each of the rows and columns that will be used to determine the length and width of the rectangle. That is column min, column max, row min and row max. In this example, the area highlighted in yellow is the minimum area that we need to return that covers all of the ones in the grid. And if we try to relate these variables to the area that we highlighted, there is a direct correlation. This is going to be the row min, this is the row max, this is going to be the column min, and this is the column max. In other words, we need to first calculate these variables to be able to figure out the rectangle that covers all of the ones. The simplest approach to solving this problem is to iterate through all of the cells in the given grid and calculate these values separately. If the value of the cell is not a 1, then we don't need to update any of these values. For example, when we iterate through the first row, there are no 1s in it, so none of these variables will be updated. But when we stumble upon the 1 on the second row, we need to update the values. As we are starting from top to bottom, the first row that we encounter with a 1 should be the R minimum because that is where we'll start our rectangle. Now we can calculate the row max by starting an iteration from bottom up and identifying the first row that we stumble upon with a 1 in it. The same approach will be used to calculate the values of column min and column max. Although the previous approach does solve the problem, there is one way we can simplify it further. We'll start off by setting the default values for all of these variables. For example, for column min, we'll set the default value to the rightmost side so that when we iterate through the cell and identify a 1, we can update it. As this is a 6 by 6 matrix, we'll use 6 as the column min, and for column max, we'll set it to -1. I'm intentionally not choosing 0 and 5 for these values because it is always possible that the entire grid do not contain any 1s in it. If we complete the entire iteration and the default values are still the same, that is -1 or 6, we know that there are no 1s in the entire grid. The same logic will be used to calculate the default values for row min and row max. Now we can start iterating through the entire grid cell by cell. If the value of a cell is 1, then we'll compare its corresponding row with row min and row max and column with column min and column max. In comparing row to row minimum, the smaller value should be saved in the row minimum variable to determine the size of the rectangle, and the higher value should be saved when comparing row to row max. Let's take the cell at 1, 2 coordinates to understand this approach better. As discussed earlier, the row min should be the minimum value between the current cell's row and the previously calculated row min. That is, the comparison is between row 1 and row min being 6. Between the two, 1 will be saved into the row min variable. We'll use the similar logic to calculate the row max, which is the comparison between the row and the row max value, and only the higher value will be saved. The row value is 1 and the row max is -1, hence 1 will be saved in the row max variable. This process will continue for all of the cells whose value is 1 on the grid. Once the iteration is complete, we will compare the values of the column min, column max, row min and row max to calculate the size of the rectangle multiplied with each other and return it as the area. With this solution, our time complexity is O of m into n, where m and n are the number of columns and rows in the given grid. This is because we are iterating through the entire two-dimensional grid only once, while the space complexity is O of 1. As we are not creating any additional collection for processing, we are using these variables to calculate the size of the rectangle that covers all of the ones. I hope you are able to understand this explanation. Let me show you how we can implement this using C#. In this C# implementation, I've initialized four variables to record the minimum row, minimum column and maximum column. On the next line, I'm starting two for loops to iterate through all of the cells in the given grid and compare its value if it is 1. If the value that my pointers are pointing is equals to 1, it means we need to include it in the rectangle. So I'm taking the corresponding row and column, comparing it with the variables that we initialized earlier and applying the min and max operation. And accordingly, the new values will be saved back into these variables. After the for loop is complete, I'm checking if the max row value is still equal to -1. If yes, it means there are no ones in the array, so I can return 0 as the output. If not, then I'm calculating the length and the width of the rectangle by comparing the values of max row, min row and max column and min column, multiplying the two values and returning it as the output. This code when submitted on LeetCode beats nearly 65% of the submissions in terms of runtime and nearly 10% in terms of memory. Thank you for watching this video. I hope you are able to understand the explanation. The details to access the source code is available in the description below. Feel free to check that out and I will see you in the next one. Thank you.